Okay, what we're going to attempt to do is to build up the Atom cart pushing robot. I have all the parts just off camera laid out here. This one we'll talk about more at the end of the build. This one I put in the gear motor that has a 1:48 or 48:1, we would say in America, gear ratio, so it's very fast. I prefer to use the 1:120. It's just a lot of the sellers seem to be sending you the 1:48 even though you ordered a 1:120. I don't know if it's bait and switch. I don't know if their suppliers made a mistake. All I know is it's getting very hard to get the 1:120s. But I have one for the robot we put together, and then we can compare the two and you can see the difference. So we'll set this guy aside for now. I can find a place to set him. And let's talk about some of the parts. This is the main body frame. It prints flat on the bed like this, no supports. And you do need something to use as a main axle in here. And in America, we use a 4-40 or a 440 screw, if you will. The 4 means it's number size 4 stock, and there's 40 threads per inch, I believe. But in this particular case, I'd run out of 440 thread stock, so what I'm going to be using is, I believe, this is metric, and I believe that's considered a 3mm piece of thread stock. And in my case, it's about 65 millimeters long. If you're doing it here in America and using the 440 thread stock, you would be sitting right at about 2 5/8 of an inch long. And if you're using the 440 here in the United States, you'll find that it actually just pushes lightly threads right through the holes. The number 3 metric millimeter, 3mm thread stock is a little bit tighter. Actually, I'd use pliers to screw it through both sides. But anyway, you want to get that piece prepped and ready like that. Let's just set that right there. One of the very first things you're going to want to do is print the cart's battery box. Now this battery box, even though it has cutout places in the bottom, those will bridge. So this part prints flat on your printer like this, no supports. Even these cutouts will bridge. There's a single thin layer of plastic where the screw is in there that bridges on the inside, so that's why there's no supports required in there either. So after you take the part off, you just take an X-Acto knife and cut that single layer of plastic out and poke holes. I printed at 0.2 layer height. You can go finer if you want, but that was fine for me. So once you've printed a part, the first thing you want to do is glue in your C-cell battery holder. This is a 2-cell battery holder, but you can also, I made the box big enough where you can use the single C-cell battery holder, so there's enough room to glue 2 singles in there or 1 double. But glue that in there first, provided holes in the bottom and up at the top, because if you use the 2 single C-cells, then you will have wires coming from the bottom as well as the top, and the wires will just run up this way. And there's a cover that you can cover this with, and again, we'll talk about that later. This is a standard little slide switch that I use in all my projects, so if you followed any of my builds you already know about it, but basically it's about 19.1 millimeters from mount hole to mount hole. You can find them on eBay and AliExpress and all kinds of places. Nothing really special about it. It's held in with a couple of 2mm screws, which normally you do have to order separately. Normally the switches don't come with the screws. But you want to prep this part first. You want to glue the holder in. You want to take one of the wires from your battery box, your 3-volt supply, and run it through the switch. So I just took the battery one, soldered it in this case to the center, and soldered what was left of the battery box wire lead to the other one, so that I can switch the power on and off to the point done. But we need to make sure you do that part up first, because as we move on it would be harder to get in here to solder and get all those things in order. So next thing we're going to want to do is you're going to want to grab whatever type of gear motor you're going to use, and this one is a 1 by 120. I prefer that gear ratio. It's a good speed and it's very powerful. And when you set it in the frame, the short part, this is the front where it says Robothut, that's the back. You're going to want to set the motor in so that the two battery connections, anyway, this is the way I do it, are on the robot's right side. I know that's the left side of the picture. Remember, from the robot's point of view, this is his right side, right, left. So set them in that way, and at that point you should find that there's the holes line up in the frame with the holes that are in the motor. And again, here in America, a 6-32 screw, or 632 as we call it, will fit and thread into the plastic, into the frame. I'm going to put 4 short ones here, here, and here, and here to hold it in. But the way this is designed, if you just had a long one with a head and you went from one side to the other and put a nut here and from here to the other nut, that would work fine too. Metric wise, I have no idea whether 632 and a number 4 are close, or if you would just use a 3. I don't know. You'll have to figure that out. But we want to screw that in to get these parts of the cart frame hooked in place and the battery box hooked in place. These both print on the cart frame laying flat on your printer like that, no supports. And the only prep that I do to them is, this is going to be down where the cart wheel is. This is up where the robot is. On this inside hole, we're going to be running a wire, which we're going to push into that hole and pull out through this slot up here. And I just take a knife and make sure that that one edge right up in here is cleaned out. So when you go to push the wire, it's not rubbing against a straight hard edge and binding. It's a lot easier to shove that wire through if you clean that out like that. And like that. And while we're talking about cleaning things out, because this prints on your printer like this, if you have elephant foot at all, you're going to want to take something and make sure you've scraped that away here, because the legs are going to use these 2 pieces as stops. And if you have an elephant leg thing going on there, that's going to make things not work quite right. So just make sure you clean that out of the way, because it's easier to do that now than it will be later. And here are my 4 632 screws. Nothing special about them. They just happen to be short with a big head, and I have a bunch of them laying around. They're actually the screws that are left over. If you've ever had to replace an AC socket or light switch in the wall in your house, these would be the screws that would be in that. They're standard. And rather than throwing them out when I throw old switches or outlets away, I normally keep the screws because it's good hardware. And in this case, it's going to be very valuable, very usable. So you're going to take a screw into each one of these holes. In this case, we're starting on the robot's left side. And just set it down so it kind of lines up like so. And I think I have a screwdriver over here. Here we go. And screw those in. Just snug. You don't want to strip the plastic, but then again, you want it to be very firm. I'm going to do the same thing on the other side. You can see the screws could be quite long. It wouldn't hurt anything. It could be one screw all the way through, or it can just be these little short ones. Point is, it's just got to be long enough to screw in and hold all of this stuff centered right. If your screw is sloppy and that motor can move around a little bit, the odds are this isn't going to walk right, because the center position of where this motor shaft is compared to everything else is critical, like within a half a millimeter. So you're going to want something that fits fairly snug and can hold everything so it can't move. Okay, what we're going to want to do now is we're going to take this part here and we're actually going to glue it into these two troughs. These wires you can just hold in the center for now. What I normally like to do is to actually put the wheels and the axles in the end of this. So let's just talk about that for a minute. These wheels print like this with no support, flat, both of them. And I just prep them with a rubber O-ring. Again, I use a kit that's available from China and Harbor Freight and places like that. I just find some sort of O-ring that will snap around it and look halfway decent. You can use anything you want for the axle. Could be wood dowel, could be plastic, could be anything. It just doesn't matter. If you have more of your 440 thread stock from earlier, use that. This happens to be a shaft that was from a Japanese, well, I can't remember which gearbox, but anyway, a gearbox kit, and it was a shaft that I didn't use. So this is considered a 3mm shaft, and lengthwise, in America, whatever you find, you're going to be at about 3.5 inches long, and if you're in the millimeter world, you're going to want to be somewhere around 90 millimeters or so in your shaft length. Nothing critical about it, because you can just, whatever you had, even if it was wood dowel, you can just glue it in there. This particular case though, using the 3mm, just poke it through the two holes, run it in, take the other wheel. In my case, I'm threading it on. Like I say, if you were gluing it on, that would be fine. And I'm not going to adjust that right now. By adjust it, I mean tighten it up to where there is or isn't any slop left in it. I just want it on there for reference, and so that way we can take a look at what's going on here. So basically, once we have glue in there, we're going to talk about putting this just like this. And normally this end piece right here is going to be about the same height as that top for cosmetic reasons. So that kind of gives you a clue where this bottom ends up. There are a couple of slots up here in the top where everything should just fit right in. So it looks like everything's ready to glue in. As you know, I printed this in PLA, and the very best glue for PLA is 3D gloop. But if you can't afford 3D gloop, since the little teeny tube of it with shipping is almost 15 bucks, you can get the number 16. Which I've got a whole video on this, so you can look that up if you're interested. This works really well. It just doesn't set up quite as fast, and coming out of the big tube like this, it's way too much glue and way too thin. But in this particular case, since I've got a channel to kind of hold everything in place, I think I'll be fine. So we put that on there, and I'm gonna set this on here. Kind of make sure everything pops in up at the top. I think we're lined up good. I'm just going to hold this for a few minutes here and give that glue a chance to bite in. Like you see, the 3D gloop is really nice because it sets up so quick, and it glues so well. I haven't had anything that I've glued with this number 16 come apart, and it's so much less expensive, and you can transfer it into smaller tubes for gluing small areas. And some of them I've added little nuts on the ends of them just because as a cosmetic touch, not because it was needed. So when this gets all done, we'll move the axle and see whether there's enough space to allow me to put the nuts on both ends for cosmetics, or whether I leave the nuts off, because it doesn't matter. They're not doing anything other than helping to add to the look of the toy. So this is probably pretty much set up, and now you can see how we've got the two wires, and we've got this hole here that we talked about earlier, and we've got this hole over here that we talked about, and basically we want to run the wire up through this part and get it sticking up. So if you've cleaned all those burrs out, or that sharp edge from the hole, you should be able to feed this wire through. There it is. Should be able to bring that wire through and pull everything up like that. There's that one. We'll do the black one. Sorry if you can't see much with my big hands in the way, but not much I can do about that. And just like that. Now there's an option at this point that's not required, and I just called this the battery box wire cover. But this little piece, if you want to use it, prints flat like that on your printer, no supports. The cutout parts will go near the top, and this piece will fit in here. So if you did have wires coming up from the bottom or anything else, it'll just go in there and kind of hides everything. Just kind of gives everything a finished look. Now you can just use it just like that. You can just snap it in and it probably won't fall out. But on the other hand, if you're sure your wiring's good and everything that you've done in the battery box was done right, and that you don't need to get to that switch again, then you could put a drop of glue on either side of the inside rails like this. You could even use a glue that maybe would let go, but something like this. And pop that down in place. When you get it right, the top of the silver should be just below the top of the gold up in here. Try to get different camera angles so you can get a good view of that. Just holds that in there. It's simply a cosmetic cover, so that's an option. It's not required to make this toy operate at all. And in fact, at this point, a person, and I think I will, I'm going to turn on the soldering iron here. You could connect up your wires to make sure that everything is working right at this point. But I think while we're waiting for the soldering iron to warm up, we'll move on to the next part. We'll actually start talking about the legs and the leg linkage. This is one leg unit assembled. And this gold part up here is the cam, yellow part is the linkage. This is the hardware that's holding together, so let's talk about what's really going on here. Start down on the foot piece. This foot piece will print on your bed flat, no supports required. And on the inside, we'll call this the inside of the leg, you can see that there's a ridged part. It looks a little different. So again, I reach into the old O-ring kit and just grab something that will stretch and snap right into those grooves and lay pretty flat. That's what's going to give the foot some traction. Not going to go anywhere. Now you're going to need something, because this piece of linkage is going to go into this back hole, just like that. This is the inside of the foot, this is the inside of the leg, these parts face the inside. We're going to need to pin that, something that'll go all the way through there, through here, and out the other side. And it can't be wider than the opening you have here. And again, it doesn't matter what that pin's made out of. It might be a wood dowel, it might be plastic, it might be an old finishing nail that you've snipped off with some snippers. In my case, I grabbed a 6-32 screw. It started off life as a 1/2 inch long, but I took just about, I don't know, somewhere between a 1/16 and an 1/8 of an inch off the end, so that I know it could fit inside this opening without, hanging up. You don't need to secure it, because once it's in place, the leg's going to keep it there. So it wouldn't matter if you used a screw with a head on it like this does, or just a plain post. Anything you use that you poke in there like that once it's assembled into the leg, you can see how that post couldn't get out at this point. So now we need to add our hinge screw in the front. And on the front, again here in America, again, this time this is a 4-40 screw, and let's see how long it is. I would say the threaded part of this is 5/8 of an inch long. So again, you can experiment in other lands as to what you might use for that joint. Perhaps a 3mm. And the whole point of it is, again, it isn't critical. I'm going to put the heads to the inside of the legs because the nut that secures this, I think, looks kind of cool. So I'm going to use the nut as a cosmetic part. So I just ran it through, pinned it to the lower leg, take a nut, and from now I'm just going to put the nut on finger tight, like so. In the end, if everything about the toy works right, I'll probably take the nut off, put a drop of Loctite on the threads, and then again put it back on finger tight. But there's no point gluing anything up solid until you're sure that everything about that is going to be working right. Alright, let's check the soldering gun here. And if everything is good to go on the soldering gun, we're going to attach these wires. I think I'm going to need needle nose so I don't burn myself. The wire and the motor had both already been tinned, so all I had to do was to heat it up. Should always pre-tin your wires and motor connectors. It makes it a lot easier. Okay, let's set that over there where I don't burn the house down. And let's tuck these wires in. The plastic mount on the motor is a convenient place to run wires through and tuck them down in. So at this point, the motor should run, which it is, when we switch things on and off. Alright, where are we at? What we want to do next is take one of these cams. There's the same rule applies on these cams. When they print flat on the bed like that, which means you might tend to get a little bit of elephant foot there on the bed around this edge, and this edge is what's going to connect all the linkage stuff. So you need to clean that edge. So either scrape that edge with an X-Acto blade, or in my case I just took some sandpaper and went around that edge on the cam and clean that off so that you don't have an extra height. And if that's all good to go, well, let's talk about the screw that's going to go into it. There is a screw that's going to go into it, so normally you're going to want to take and make sure that that hole is clean. You could use almost anything for this pin, but here in America, this is a 256 or 2-56 screw. And the length, looks like about this. It's not actually critical. I think a 1/2 inch would be fine. This is just a little bit under a 1/2 inch. And a small washer, a number 2 washer, is not needed to make this thing work, but I like to use it. I think it can make things more reliable in the end. But once we start assembling it, let's go back here. Once we start assembling it, that screw is going to self-thread into there. So if you had something that didn't self-thread, then you could always put glue in there and push it in and super glue it. There's actually enough room here on the back because this sticks out and then that sticks out from the motor, that a nut could be back there. You could put super glue back there. There's a lot of ways you could secure whatever you end up having to use wherever you are in the world. But you can see the cam just gonna pressure fit on like that. And now if we turn it on, you should be able, easier to see the motor running because the cam's going around. And as we stated earlier, the rubber part, the knobs, the parts that stick out of linkage, that all is the inside, so that means that this foot has to go on this side. When you push it onto the 3mm, then you want to make sure that you line up into this slot down here too. So catch the slot, because that's a pivot point. Catch the other part of the leg, just like that. Now we're going to swing this over and put our screw into that hole, like so. So I can't do it and stay out right up into the camera's face. Gonna call screwdriver here. So in my case, it's cutting threads right into it. I normally take them down all the way and then back them out a little. So at this point, if we were to test it, we should have our one leg operating. So when you're looking at it from this side, the motor should be rotating clockwise from the robot's left side. Now there's another optional part that you don't have to use. It's this side panel. You could just put a nut on here to keep that leg in place. But I use a side panel that goes on like this. And then in this case I'll put a nut on there. And again, for now I'm going to put that on finger tight. If everything works in the end, I'll take that nut off, put a drop of Loctite on there, and put it back on finger tight. Keep everything in place. Now basically we're just going to do the same thing on the other side. The other side we already have assembled, so it'll be a little bit harder maybe for me to pop this stuff on, but we'll give it a shot. We need to turn this around. Let's see, if that's up like that, then this would be something like this. See, the two cams are going to go 180 degrees out of phase with each other so that you can get the walking action going between both legs. Like so. And again, since I'm using the covers, we'll put the cover on. Put a nut on there. Which is fighting me. I think it's because that's the end of the thread stock that I cut, so it wasn't perfectly square. Just put that down finger tight because you don't want to crush the plastic in. So we're basically done. I mean, at this point the toy should walk, and it does. But to finish off the looks and everything, the two arm parts both print down flat on the bed like this. All this inside stuff will bridge, but you do need support at the ends. So in my case, I'm using the Prusa slicer. I just told it to add supports, and it already has a don't add supports wherever it can bridge, so it automatically won't fill that in. So it put just supports right here at the end and in this end, and when after it's done printing, I just took my finger and pulled those pieces out. It was that easy. But again, because this part prints down, you might have a little bit of elephant foot on this edge, so you're going to want to take sandpaper or a knife and clean these two inside edges, otherwise this isn't going to want to pop on. And you can kind of see how I've routed that wire. There's a slot up here for it, and then this piece, you're going to find that this piece will, if everything is set up right, will just pop on. And once again, in the end, for example, when I build and ship these to friends, I'll go ahead and glue this on because I wouldn't want it to fall off in shipment and have them try to figure out how to build something. But I wouldn't suggest gluing any of these parts on until you're sure everything is working and looking the way you want. Or if you ever want to be able to take the thing apart and do anything with it, you're going to want to leave that separate. So that brings us down to the cosmetic head. Head prints flat on the bed. Again, no supports required. I do line the mouth with a little aluminum foil tape. Or just lay it over there, press it in, cut it, seal around, trim off the excess. Gives the mouth a little bit a standout. But that's just going to fit over the motor. And again, if you know you're done with your project, then you'll just go ahead and dab some glue around this bottom one and set it right down in place. And that's that. Now, as far as the front of the battery pack, there's no reason you can't just leave it as he's pushing batteries around. That's totally fine. So I consider the cover as an option. In my case, I added details to the very front of the cover to kind of make it look like an old reel-to-reel machine. The files that I'm going to provide on Thingiverse for all this is going to be a plain front. It will cover it, but there'll be nothing on there. That way you can add whatever details you want to it. And the plain one can print flat like this, and all those things can come up. Once you've added details to it, obviously it's going to have to print like this, and then you'll need to turn on supports to get this little edge, which is that ridge, which is what holds it in place. So you can get to the batteries or cover it up. And I believe that's it. We should be done. And that is the robot walking with a 120:1 gear ratio, and this is using the 148 or 48:1 gear ratio. It's a faster gear ratio, but because of the mass of the toy and because you lose torque with a faster one, it does slow down a little bit, but it is quicker. Moves right along, as you can see. Yeah, let's get these two guys kicking side by side here. So you can see they're almost 3 times faster, 2 point something times faster than the other one. So if your goal is to make a racing cart now, then you might want to use the 1x48, which is the easiest one to get. Everyone on eBay sells the 1x48. You can get it anywhere. This has got the 1x120, which I kind of like the walking speed of. And so far, all of the people that I find trying to say they're selling that one are actually going to send you the faster one. And we're not really sure whether the sellers are lying or whether the part suppliers that give the motors to the sellers have told the sellers the wrong thing, and they're working on good faith, but it's wrong. It's hard to say. I did find one seller that was selling the 1x120 in a single shaft version. So I bought a few of those to finish up some of my mini dual drive base, which you can find as some of my other projects that I did, like my Radicon and Sonicon. I took care of those. But I also did take 2 of these and basically just took the motor and the gears out of this and stuffed them into the 1x48 gearboxes, and that gave me the slower speeds that I needed on that first build of 4, which you can see on YouTube as well. So you can mod them and make them if you want, or you can just go super fast, or you can just go slow if you can track down the motor. But anyway, that's the build. The files will be up on Thingiverse, and have fun with it.